Yes, good morning, students. Good morning, all of you. This is Kidev Online Academy, your big channel in East Africa and all over the Africa. And today you are with me, your teacher, Mr. Kidevo, and we continue with our lesson, which is mathematics. And today we are straight going to start a new topic, which is new chapter number 1, topic number 1 in Form 1. And this is a number. Our new topic is number. Yes, numbers. Yeah, everybody is or she's familiar with this word. We always use this word in different activities, in different locations, in different occasions. For example, if you you want to know your age, maybe, for example, your age is 32 years. Now, if it is 32 years, it means 32 here is a number. Or for example, if you take your body height, maybe you are 160 centimeter high. It means this is your body height. So 160 is a number. Or for example, if you measure maybe the bags of rice, we have maybe 20 kilograms of rice. Now this 20 kilogram is a number. Or for example, if you want to measure the capacity of volume of a liquid, for instance, maybe cooking oil, we have maybe 5 liters of cooking oil. 5 liters of cooking oil. Now this 5 is a number. So what is a number? So simply, according to these examples, it means we are familiar with this term, and always we use the term number, and we are familiar, always we use this term. For example, here 160 is a number, 32 is a number, 20 is a number, and 5 is a number. Now, what is a number? By definition, if we speak about number, this is a mathematical object that represents quantities or measurements. This is a mathematical object that represents different quantities or measurements. So by definition, number is a mathematical object that represents different quantities or measurements. Yes, so this is a number. Is a mathematical object that represents different quantities or different measurements. Now, for example, in quantities, if you have what I said, maybe 20 kilograms of rice. Now, for example, example number 1, if you say in quantities, if you have maybe 20 grams of rice. Or for example, we have 50 liters of cooking oil. Now in 20 grams of rice, this 20 is a number. 50 liters of cooking oil. Now this 50 liter is a number. It means this 50 is a number. Or 45 newtons of your body weight. Yes, maybe someone has a weight of 45 newtons. Now this 45 is called a number. Or sometimes if you have maybe the temperature of a day, it can be maybe 30 degrees Celsius of temperature. Temperature in a room. Now this 30 is called a number. So that is the number, and this is the how we can use number in different quantities. For example, here is 20 grams of rice, 50 liters of cooking oil, 45 newtons of your body weight, 30 degrees centigrade of temperature in a room, etc. So all of these are numbers. But also in measurements, because we paid, number is a mathematical object that represents different quantities of measurements. Now in measurements, if you talk about maybe the distance of a road, maybe the road is 450 kilometers. The road is 450 kilometers. It means here we are talking about the length of the road. Now the road is 450 kilometers. So this 450 is a number. So that is a number. Then let us see the co-function. Where can we apply the concept of number? The co-function of a number. Co-function of a number. Now, number is used in different places. For example, number are used for counting. So, number can be used in different places. For example, one in counting. Yes, in counting. The second one is in measurements. But also in labeling. In labeling objects. Now in counting, for example, if you say the number of students in a class are 50. So, for example here, 50 students are in class. 50 students are in class. So this 50 is called a number. That is number applied in counting. But in measurements, if you say maybe 250 kilometers of the road, it means the length of the road is 250 kilometers. So this number have been applied in measurements. But also in labeling, if you have, we know the bottles of water or sometimes soda, they are labeled. Maybe we have 350 milliliters of maybe Coca-Cola. 350 milliliters of Coca-Cola. It means this 350 now is a number. So these are different uses of a number. We are always apply this concept in different situations or different places. So those are the core function of a number. Or for example, you can say the population, other uses of a number. Maybe if we take the population of maybe Tanzania, we are about 60 millions. So the population of Tanzania citizen is 60 millions. 60 millions. Now, this 60 millions is a number. Yes. Then after that, let us see now representation of a number. How can we represent a number? Representation of a number. Representation of a number. Representation of a number. Numbers are represented by symbols which are called numerals. So the numbers are represented by symbols which are called the numerals. Which are called the numerals. Yes. For example, if you have 54. Now 54 is a number which is a numeral. So all of this is a numeral. So 54 is a number which is a numeral. Also, maybe 138. 138, this is a number, but also this is a numeral. So this is a symbol which is used to represent the number 138. But also this is a symbol which is used to represent a number which is 54. Or we have maybe negative 68. So negative 68, this is a number which is represented by this numeral. Yeah, so this is numeral, this is numeral, this is numeral. If you write maybe 98, also this is numeral. So a number 98 is represented by this figure, which is a numeral, etc. We have so many examples of numbers. So numbers are always represented by a special symbol which are called the numerals. Now these numerals are made up by another symbols, another signs of a number which are called the digits. So inside the numerals we have digits. For example, we said this 54. 54 is a number which is represented by this numeral 5 and 4. But in this number or in this numeral which is 54, we have two signs which are used. These symbols also are 5 and 4, and these symbols inside the numeral are called the digits. So numerals are also made up by small symbols which are called the digits. Notes? So numerals are made up by other symbols which are called the digits. And these digits, we have almost 10 digits. It means any number, any numeral is made up with one, at least one among of those 10 digits. So there are 10 digits which make different numbers. And these digits are, yes, we have the first digit which is 0. So you have 0. We have 1, 2, 3, 4, 5, 6, 7, 8, and the 9. Yes. So these are digits which make any number. If you write any number, it means you have to use one among of these 10 digits. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have almost 10 digits which make any number. For example here, if you write your number maybe 234, this is a number which is a numeral. But in this number 234, we have 3 digits. The first digit is 2, which is here. The second digit is 3, which is here. And the third digit is 4, which is here. Another example is maybe you have 2,838. 2,838. This is a number which is a numeral. And in this number we have how many digits? 1, 2, 3, 4, whereby 8 repeats. So we have the first digit which is 8. We have the second digit which is, the first digit is 2. The second digit is 8. The third digit is 3. And the last one is 8, whereby 8 repeats. Also, we have maybe, for example, we write a number, maybe it is 58. Now, 58 is a number. Is a number or numeral. This is a number or numeral. But in this number has 2 digits. The first one is 5, which is here. The second one is 8, which is here. That's why we said if you write any number, it means you will use one among of these 10 digits. Or if you write maybe negative 10, this is a number. Negative 10 is a number or numeral. And in negative 10, we have 2 digits, whereby the first one is 1, which is here, and the second one is 0, which is here. So all numbers which you know, they made up with small symbols which are called the digits. And we have about 10 digits. The first is 0, 1, 2, 3, 4, 5, 6, 7, 8, and the 9. Yes. Not. So each numeral is made up with either one or more digits. Each numeral is made up with either one or more digits. Yes. Each numeral is made up with either one or more digits. Yes. Now, after that, let us discuss about the types of numbers now. Types of numbers. Types of numbers. Yeah, so far we know about different types of numbers. We know about the whole numbers, real numbers or counting numbers. We know about the even numbers, odd numbers, prime numbers. We know about real numbers. We know about fractions. We know about decimals. But all of these numbers, we know about integers. We know about positive numbers, 0, negative numbers. All of these are numbers. Fractions, decimal, all of them are numbers. But all of these numbers have been grouped into 2 main types. So generally, we have 2 main types of number. We have 2 main types of numbers. So there are 2 main types of numbers. 2 main types of numbers. And these are, here we are talking about the rational numbers and the irrational numbers. So these are the main two types of whole numbers. So these are, we have the first, which is rational numbers. We have the second one, which is irrational numbers. Yes, so these are the only main types of whole numbers. All numbers which you know, they fall under these two types of numbers. If you speak about integers, if you speak about negative numbers, zero, positive numbers, fractions, decimals, whole numbers, natural numbers, counting numbers, fall under these two rules. So you have to go one after another. What is rational number? What is irrational number? Very simple. Now let us start with the first, which is rational number. Rational What type of numbers are these? As you see the name rational, it is coming from the ratio. Ratio is fraction, something like that. So rational numbers, these are all numbers which are be expressed in terms of fractions, or these are numbers which can be expressed in terms of A over B. So all numbers which can be expressed or which can be written in the form of A over B, or numbers which can be written in the form of fractions, these numbers are called rational numbers. So these are all numbers which can be written in the form of A over B. It means fractions. So all numbers which can be written in the fraction form, or all numbers which can be written in the form of A over B, these are called the rational numbers. Yes, these are called the rational numbers. For example, if you have maybe 1 over 2, 1 over 2 is a number which is written in the form of A over B. It means A is 1 and B is 2, whereby 1 over 2 is a fraction. So 1 over 2 is an example of rational number. This is a rational number. Yes. Another example is if you write maybe 7. Now 7 also is rational, because if it is 7, then it is 7 over 1. There is 1 which is there down. Normally it is not written, but it is there. So it is 7 over 1. So if it is 7 over 1, then this is becoming a rational number, because it has been expressed in terms of fraction, or it has been expressed in terms of A over B. So also 7 is a rational number. Another example is if you have maybe negative 6. Now negative 6 also is irrational, because this negative 6 can be expressed as negative 6 over 1, which is a rational number. Also, we have numbers like decimals. For example, if you have 0.25, now 0.25 also is irrational. Why? Because 0.25 is a number which can be expressed in terms of fraction, which is equal to 25 over 100. Now, if it is 25 over 100, then this is a fraction form, or it is a form of A over B. So also 0.25 is rational, because you can express this 0.25 in terms of fraction. So also this is a rational number. Yes. Another example is if you have repeating decimals like 0.3, whereby 3 repeats, 0.3, whereby 3 repeats. So 0.3 whereby 3 repeats also is a rational number. This is repeating decimal, but it is a rational number because if you change into fraction, it will be equal to 1/3. I'll show you later how to change this into fraction. But if you change into fraction, it will be equal to 1/3. Then 1/3 is a number which is written in the form of A/B, which is a fraction, which is a rational. So this also is a rational number. Yes, so this also is a rational. So all of these and other examples of numbers which can be expressed in terms of A/B, those are called the rational numbers. They are called the rational numbers. Yes. Then after that, let us see now about the categories of rational numbers. Categories. Categories or types of rational numbers. Categories or types of rational numbers. We have varieties of or types of rational numbers. We have different types of rational numbers. So here there are various types or categories of rational numbers. These are, yes, the first is, we have the first group which is integers. So the first group is integers. All integers are rational numbers, but you have the second group which is fractions. All numbers which are fractions are rational number, fractions. We have the third group which is terminating decimals. We have terminating decimals. We have terminating decimals, but also we have repeating or recurring decimals. The fourth group is repeating or recurring decimals. Repeating or recurring decimals. So these are types of rational numbers. It means, according to the definition of rational numbers, it means all of these numbers can be expressed in terms of fractions, can be expressed in terms of A/B. Yes. Now let us start by looking the integers. What is an integer? Examples of integers and how an integer is becoming a rational number. The first group is integers. Integers. Now integers, if we talk about integers, these are positive and negative whole numbers. If we talk about whole numbers, means here we are excluding fractions, we are excluding decimals. So these are positive, negative whole numbers including 0. So integers are all positive and negative whole numbers. Whole numbers including 0. Yes. So in integers, we exclude the fractions, we exclude the decimals. In integers, there is no fractions, all decimals. Yes, so if there is no fractions and decimals or decimals, it means integers is dealing with the whole numbers. For example, examples of integers, let us start with the positive integers. Positive integers. Now, positive integers, we have numbers like maybe 2, 8, 6, 9, 10, 15, 20, 58, 100, etc. All of these are positive integers. But also we have negative integers. Negative integers. Now, negative integers, we have numbers like -1, -2, -3, -4, -5, -6, -7, -8, -9, etc. So all negative numbers which are whole, all negative whole numbers, they fall under the negative integers, and all positive whole numbers, they fall under positive integer. But also the third group of integers is 0. Now 0 also is an integer. So this is an integer, and these are examples of integers. Then we have the second group of rational numbers, which is fractions. The second group is fractions. What is a fraction? A fraction number is a number which can be expressed in the form of A over B. A fraction number is the one which can be expressed in the form of A over B, whereby A is any number and B is not equal to 0. So A is any number or any integer. Yes, A is any integer and B must not be equal to 0. Examples of fraction numbers. Examples are, if you have 1 over 2, this is a fraction number. If you have 3 over 8, this is a fraction number. If you have -6 over 7, also this is a fraction number. If you have 5 over 3, this is a fraction number. If you have 9 over 11, also this is a fraction number, etc. We have so many numbers which are fraction. So this is the second group of rational number. Then we have terminating decimals. The third group is terminating decimals. The third group is terminating decimals. What are these? These are decimals, all decimals which have an end. It means they will not continue up to infinity. You know, these decimals, we have two categories. There are those which they don't have an end. So if you talk about terminating decimals, it means these are decimals which have an end. Yes. So these are all decimal numbers which have an end. Yes. So they end. For example, if you have 0.5, it means 0.5 is the last number. So it ends up here, 0.5. So this is terminating decimal, whereby terminating decimal, which is 0.5, it can be written as 5/10, which is a rational. Remember, we are discussing about the categories of rational number. So 0.5 is terminating decimal, and if it is terminating decimal, it can be changed or it can be converted into fraction. And we said all numbers which can be converted into fractions, they fall under the first type of number, which is a rational number. Or if you have maybe 0.25. Also, this is a terminating decimal because here it is the end. It will not continue up to infinity. And these terminating decimals can be changed into fraction, which is equal to 25/100. Now, 25/100, this also is a fraction number, which is a rational number, because all rational numbers can be expressed in terms of fraction. They can be expressed in terms of A/B. Another example of terminating decimal is maybe if you have a 1.3. 1.3, it means this decimal, it does not contain, and this is an end. So 1.3 is a terminating decimal, and if it is terminating decimal, it can be changed into fraction, which is equal to 1/3, which is 13/10. Now 13/10 is a fraction number. Now since it is a fraction number, it means terminating decimal is what? Is a rational number. So these are examples of terminating decimals, and we said all terminating decimals they fall under the first type of number, which is rational number. Yes. Another type of rational number is repeating or recurring decimal. The fourth group is repeating or recurring decimal. Yes, repeating or recurring decimal. What type of decimals are these? These are all decimals whereby there is 1 or 2 or 3 digits repeats after a decimal point. So after a decimal point, there are some digits which repeat. It has no end, but there are some digits which are repeat. So because of this, now this type of decimals, we are calling them repeating or recurring decimal. It means we have some digits which repeat, and those digits, they are after a decimal point. So we call this type of decimal to be recurring or repeating decimal. So these are all decimals which they have some digits. They have some digits after a decimal point.